Hello everybody, welcome into another lesson. So today we are going to apply what we've learned so far in the trigonometry unit to first part of the lesson is going to be solving right triangles, and the second part of the lesson is going to be finding altitudes of isosceles triangles. So let's get started with the first example. So for the first one, they give us that angle A is 30 degrees, and then they give us that side B has a length of 10. We have to solve for all the missing parts of this right triangle. It's probably best if you're given a degree of a right triangle and a side, I would say first find the missing angle. We know angle C is the right angle. We can clearly see that. Well, there's a shortcut. If we remember all the way back to geometry, we know that there's a theorem that says that the angles of a right triangle are complementary to each other. So that means that the measure of angle B is going to equal 90 degrees minus 30 degrees, which would then give us that the measure of angle B equals 60 degrees. So we solved for the missing angle. Now what we have to do is solve for the two missing sides. Well, we only know one side. I'm going to vote we go in alphabetical order. Well, we should probably work based on the original angle we were given. So we can solve for A quite easily, because if we look at the 30-degree angle, the tangent of 30 degrees is A over 10. So go ahead and set that up. You'll take the tangent of 30 degrees equals A over 10. Now we can easily solve for A, because A is going to equal 10 times the tangent of 30 degrees. And then we're going to get a decimal place approximation to two decimal places. So then we can get that side A is going to be equal to this. So make sure your calculator's in degree modes when you do this, because if it's in radians, you'll definitely get a wrong answer. Alright, degrees, there we go. So we need 10 times the tangent of 30 degrees to two decimal places would give you a length of approximately 5.77 units. So A is approximately equal to 5.77 units. Then we need to find side C. Well, if we look at the 30-degree angle again, the cosine of 30 is 10 over C. So here's what we can do then. Take the cosine of 30 degrees, adjacent over hypotenuse, that'll equal 10 over C. So then C times the cosine of 30 degrees equals 10, and then you'll have that C equals 10 divided by the cosine of 30 degrees. And then now if you just put that into your calculator, you should end up getting a two decimal place approximation. So see, the cosine of 30, you get that, and then take 10 and divide by that answer. You end up getting a length of about 11.55 units if you round to two decimal places. So now we have solved for the missing parts of this right triangle. Angle B is 60 degrees, side A is approximately 5.77 units, and side C is approximately 11.55 units. And I got more of these. Okay, so We are given this time that angle B equals 60 degrees. And then we're given that side C equals 15, which is going to be our hypotenuse. So we know one angle and we know the length of one of the sides of the triangle. So first thing, again, I would say we solve for the missing angle since we know one of the angles. So that means that the measure of angle A is going to end up being 90 degrees minus 60 degrees, which just gives you that A equals 30 degrees. So we just found the missing angle A, it's 30 degrees. Okay, well, let's go in alphabetical order again. If we want to solve for A, the cosine of 60 is A over 15. So let's go ahead and set that ratio up. Cosine of 60 degrees equals A over 15, which means that A equals 15 times the cosine of 60 degrees. And then we can get a 2 decimal place approximation. So let's just take 15 times the cosine of 60. You actually end up getting exactly 7.5 units. So you actually get an exact answer of 7.5 units. And that makes sense because in a 30, 60, 90 right triangle, the hypotenuse is exactly twice that of the shorter leg, which A is. Alright, now to solve for side B, we can use the sine ratio. So the sine of 60 equals B over 15. So we'll set that up. The sine of 60 degrees equals B over 15. So that means that B equals 15 times the sine of 60 degrees. And now we can get a 2 decimal place approximation for side B. So 15 times the sine of 60 to 2 decimal places gives you a length of about 12.99. So B is approximately equal to 12.99 units. All right. Let's see what we got now. We're given this time that angle B equals 71 degrees, and then side B equals 14. So we're given another angle and a side. Well, I would solve for that missing angle A first. So that means that the measure of angle A equals 90 degrees minus 71 degrees, which would give you that angle A itself is equal to 19 degrees. So now we found angle A to be 19 degrees. From here we can find the sides. And what a better place to start than find side A. So we can use the tangent ratio for 71. So the tangent of 71 degrees equals 14 over A. So we'll set that up. The tangent of 71 degrees equals 14 over A, which means that A times the tangent of 71 degrees equals 14. So then A would equal 14 divided by the tangent of 71 degrees. And then now we can get a 2 decimal place approximation for side A. So let's see, the tangent of 71 degrees, then we'll take 14 and divide by that. You get approximately 4.82 units for A. So A is approximately equal to 4.82 units. And there's a reason why I'm not using Pythagorean theorem to find the third side, because everything we're doing is based on approximations. If I try to use Pythagorean theorem now, that could slightly throw off what I'm going to get. We want to get as accurate of an approximation as possible. That's why we continue the way we're doing with these angles. Okay, so we have A. Now, if we look at the 71 degree angle, we know opposite over hypotenuse is the sine ratio. So we can find C. That means that the sine of 71 degrees equals 14 over C. So C times the sine of 71 degrees equals 14. So C equals 14 divided by the sine of 71 degrees. And then now we can get a 2 decimal place approximation. Nope, that's not what I wanted, not at all. Now let's take 14 and divide by that. You get about 14.81 units. So your hypotenuse C is approximately equal to 14.81 units. All right. Let's see what we're given this time. Angle A is only 7.4 degrees. So angle A is 7.4 degrees. Side A has a length of 20.5. So we have another angle and another side. Well, again, since we have an angle, let's solve for the missing angle, which would be B. So the measure of angle B is going to be equal to 90 degrees minus 7.4 degrees, which means B is going to be equal to 82.6 degrees. So you get that angle B is 82.6 degrees. Okay. Well, we found the missing angle, but we don't know sides B and C. However, we can use the tangent ratio for 7.4 degrees, and we can find that the tangent of 7.4 is 20.5 divided by B. So the tangent of 7.4 degrees equals 20.5 divided by B, which means that B times the tangent of 7.4 degrees equals 20.5. So then B equals 20.5 divided by the tangent of 7.4 degrees. Now we should be able to get about a 2 decimal place approximation. So let's deal with all this. Alright, so the tangent of 7.4 degrees, and then let's take 20.5, divide by that answer. To 2 decimal places, you get approximately 157.84 units. So side B has a length of approximately 157.84 units. Now let's go for side C. Well, we can use the sine ratio for 7.4 degrees. So the sine of 7.4 degrees equals that 20.5 divided by that side C, which means that C times the sine of 7.4 degrees equals 20.5. So that means that C equals 20.5 divided by the sine of 7.4 degrees. Now we should be able to get about a 2 decimal place approximation for side C, the hypotenuse. Alright, so the sine of 7.4, you end up getting that, and then take 20.5, divide by that answer, you get about 159.17. So the hypotenuse, which is side C, has a length of approximately 159.17 units. Alright, now we're going to change this a little bit. So, let's see. This time, we are given that side A equals 6. We're given that side B equals 12. So we don't have a clue what any of what angles A or B are. We know side C is angle C is 90, but we don't know angles A or B. If you're given two sides, the first thing you probably want to do is use Pythagorean theorem to solve for the two sides. So this for the missing side. So you'll take 6 squared plus 12 squared equals C squared. And then, let's see, so this would turn into 36 plus 144 equals C squared. So this would give you that C squared equals 180. So then C equals the square root of 180, which I want to see how that breaks down. Well, let's see. That's going to break down into the square root of 9 times the square root of 20, which would mean it breaks down into the square root of 9 times the square root of 4 times the square root of 5, which means that C equals exactly 3 times 2 is 6, then times the square root of 5. So side C would equal exactly 6 times the square root of 5. Let's get a 2 decimal place approximation for it. Let's see, 6 times the square root of 5 is about 13.42. So side C equals exactly 6 times the square root of 5 units, or approximately 13.42 units. Well, okay, so now we want to try to find one of the angles. I think it's pretty obvious we want to go for A, because the tangent of angle A equals 6 over 12, which would simply be 1/2. Which means that A is going to be equal to the tangent inverse of 1/2. The way to solve for the angle is take the inverse function. So A equals the tangent inverse of 1/2, and then we should be able to get a decimal approximation for that to 2 decimal places. So let's see, let's take the tangent inverse of 1/2. In degrees, you get approximately 26.57 degrees. So we found angle A to be approximately 26.57 degrees. So now for angle B, we can simply just take this away from 90. So angle B is going to equal 90 degrees minus that 26.57 degrees, and this will also be a 2 decimal place approximation since angle A was. Alright, so let's see, 90 minus 26.57 gives you approximately 63.43 degrees. So we get that angle B is approximately 63.43 degrees. So yes, it is a little bit different when you don't know any of the two angles of the right triangle and you're only given two sides. Probably going to get another black marker real quick. Here's side A, here's side B for reference. Okay, let's see here. Side A has a length of 25. Side B has a length of 45. Wait, that's not side B. This is side C, excuse me. Side C has a length of 45. So we're once again given two sides, but we don't have a clue what the two angles are yet. Well, first I would say we solve for side B. So this means that 25 squared plus that B squared equals 45 squared. And this is going to be pretty horrendous. So that means we get B squared plus 625 equals to, let's figure out what the heck 45 squared is. 45 squared equals 2025. Which then means that B squared should equal 1400. So then you'll end up getting that B equals the square root of 1400, which would literally be the square root of 100 times 14. So you get that side B has a length of 10 times the square root of 14, which now we can take the decimal approximation to two decimal places. So 10 times the square root of 14 gives you a length of approximately 37.42 units. Alright, so side B is exactly 10 times the square root of 14 units, or approximately 37.42 units. Now, let's go ahead and find angle A. Let's start there. We can use the sine ratio since we have the opposite side and the hypotenuse. So the sine of A equals 25 over 45, which means that A itself would equal the sine inverse. Now, what is 25 over 45? That's 5/9. That's a much simplified form. So now we can get a two decimal place approximation for the angle A. Let's find the inverse sine of 5/9. For angle, let's see, you get about 33.75 degrees. So you get that angle A is approximately equal to 33.75 degrees. And then finding angle B is going to be easy. Just subtract that 33.75 from 90. That's going to equal 90 degrees minus 33.75 degrees, which means angle B will also be an approximation. Let's take 90 minus 33.75. No, not plus. I need minus. You get about 56.25 degrees for B. So then you end up with angle B is approximately 56.25 degrees. Alright, so here's side A, here's side C. Let's see what we got now. Alright, we're given that side B has a length of 16. And then we're given side C has a length of 54. And of course we don't know angles A or B. Well, let's use Pythagorean theorem to solve for side A. So this would end up being A squared plus 16 squared equals 54 squared. So that means that A squared plus 256 is equal to whatever the heck 54 squared is. This isn't going to be a fun one. You get 2,916 for 54 squared. So then that means that A squared equals at 2,916 minus 256. You get 2,660. So A would equal the square root of that 2,660. We're just going to deal with the decimal approximation anyway. To two decimal places, you get approximately 51.58 units. So you do end up, in fact, getting that side A is approximately 51.58 units. Now we got our sides, let's find the angles. Well, if we look at angle A, we can use the cosine ratio. You have 16 over 54. So we could set this up as the cosine of angle A equals 16 over 54, which means that A is going to equal the cosine inverse. 16 over 54 in reduced form is going to be 8 over 27. So now let's take the inverse cosine. We'll get an approximate angle measure of angle A. Alright, so our cosine of 8 divided by 27 will give you an approximate angle of 72.76 degrees. So you get that angle A is approximately equal to 72.76 degrees. Now we can easily find B. The measure of angle B is approximately equal to 90 degrees minus that 72.76 degrees, which means that B will have an approximate measure of whatever that result is. I think 17.24. Yep, 17.24 degrees. So the measure of angle B is approximately equal to 17.24 degrees. Alright, I got 3 more of these right triangle ones. Then we're going to do 4 exercises based on finding the altitude of an isosceles triangle. So let's see, here's side B, here's side C. What do we got this time? So side B has a length of 1.32. And then Side C has a length of about 18.9. So this is going to be fun. Well, we need to use Pythagorean theorem to find side A first, since we don't know any of the angles. So this means that A squared plus 1.32 squared equals that 18.9 squared. Which means that A squared equals that 18.9 squared minus that 1.32 squared. So then A would equal the square root of all that. And there's a reason I'm not doing the squares yet. I want to take this all as one answer because we want to get the most accurate decimal approximation possible. If you round too soon, you could end up being off a little bit, or a lot even. So here's how I'm going to do this. In my calculator, what I would do is, in parentheses, put that 18.9. Actually, let's put a second set of parentheses. So the 18.9 raised to the second power with the parentheses around it, minus, in double parentheses, that 1.32 to the second power. And then I can take I get about 355.4676, and now if I take the square root of that answer, I get a side length of approximately 18.85 units. So side A has a side measure of approximately 18.85 units. So now we know side A. Let's work on finding angle A. Again, we'll use the cosine ratio. So the cosine of angle A equals 1.32 over 18.9, which means that angle A itself is going to equal the inverse cosine of 1.32 over 18.9. And then we should be able to get a 2 decimal place approximation for the angle. Okay, so 1.32 divided by 18.9. Now let's take the cosine inverse of that answer. You get approximately 86 degrees. So angle A would be approximately 86 degrees, which means that the measure of angle B is approximately equal to 90 degrees minus that 86 degrees, which would give you that angle B is approximately 4 degrees. That's what you would get. Angle B is approximately 4 degrees. All right, 2 more of the right triangles, and then we're going to move on to 4 of the isosceles triangles examples. All right, so here's side B, here's side C. What do we got this time? We got that angle A. Now this is interesting. We have 12 degrees and 15 minutes. And then we got that side C is 430.5. Okay, well, we definitely need to deal with this angle A first. We have an angle on a side. Well, let's deal with angle A. We know that angle A equals 12 degrees and 15 minutes. What's probably going to serve us well is just to convert this into degrees, because it can be kind of tough to put in the degrees and minutes into the calculator. So that's equal to 12 degrees plus 15 minutes is 15 out of 60 degrees. Well, what's 15 out of 60? That's a quarter, right? So that means that angle A would equal 12.25 degrees. So this is the same as 12.25 degrees. Now, we could find angle B pretty easily by subtracting that from 90. So that means the measure of angle B is going to equal 90 degrees minus 12.25 degrees, which means that angle B itself is going to end up equaling, so that would be 77.75 degrees. That's one way to write angle B, or if you want to convert it to degrees and minutes, so angle B would equal 77 degrees plus 3/4 of a degree, which means that angle B would equal 77 degrees plus 45 out of 60 degrees, which means that angle B itself, if you wanted to write it in degrees and minutes, would be 77 degrees and 45 minutes. So if you want to convert it to degrees and minutes, angle B would be 77 degrees and 45 minutes. Okay. Now, we can find the sides. So let's work with angle A as 12.25 degrees. We can use the sine ratio to find side A because the sine of that 12.25 degrees equals side A over 430.5, which means that A equals 430.5 times the sine of 12.25 degrees, which now we should be able to get a 2 decimal place approximation for side A. Which would give you about 91.34. So side A has a length of approximately 91.34 units. Now let's find side B. That can be found using the cosine ratio of angle A. So this means that the cosine of 12.25 degrees equals that side B over 430.5, which means that B equals 430.5 times the cosine of 12.25 degrees, which means now we should be able to get a 2 decimal place approximation for side B. Which would give you about 420.7. So side B would be approximately equal to 420.7 units. And I got one more of these type, of this one, and then we'll move on to the 4 isosceles triangles. Alright, here's side C. Let's see what we got for the last one. Angle B is equal to 65 degrees and 12 minutes. Side A is 145.5 units. So once again, we have a degree measure and a side. Well, since angle B's in degrees and minutes, we should probably convert this into just degrees. So we know B equals 65 degrees in 12 minutes, which means it equals 65 degrees plus 12 out of 60 degrees. 12 out of 60, well, that's 1/5. So that means that angle B would end up equaling 65.2 degrees. So there's your decimal converted all into degrees for angle B. It's 65.2 degrees. Now, let's solve for angle A. So that means the measure of angle A would equal that 90 degrees minus that 65.2 degrees, which means that A itself is going to then end up equaling 24.8 degrees. So that's one way you can write angle A is going to be 24.8 degrees, or if you want to convert this into degrees and minutes, we can do that. So angle A equals 24 degrees plus 0.8 of a degree, which means that angle A would equal 24 degrees plus 48 out of 60 degrees. So angle A in terms of degrees and minutes is 24 degrees 48 minutes. So if you wanted to write angle A in terms of degrees and minutes, it's going to be 24 degrees and 48 minutes. All right, so we have our angles. Let's find side B. Let's stick with our original angle of that 65.2. Well, we know we can use the tangent ratio, which would be B to 145.5. So if we take the tangent of 65.2 degrees, that equals side B over 145.5 for your side. So B equals 145.5 times the tangent of 65.2 degrees. So now we should be able to get a 2 decimal place approximation for this. All right, so 145.5 times the tangent of 65.2 gives you a length of approximately 314.89. So side B is approximately equal to 314.89 units. Now we can find C. Well, we can use the cosine ratio with angle B, because the cosine of that 65.2 degrees equals your adjacent side of 145.5 over side C. So C times the cosine of 65.2 degrees equals 145.5, which then means that side C equals 145.5 divided by the cosine of 65.2 degrees. So now we should be able to get a 2 decimal place approximation for side C, the hypotenuse. All right, so 145. No, let's not do that. Let's do the cosine of 65.2 first. Then take 145.5 and divide it by that answer. You get a length of approximately 346.88 units. So the hypotenuse side C would be approximately equal to 346.88 units. Alright, so that's it for the right triangles. Let's move on to some isosceles triangles, and there's only going to be 4 of them. So let's see here. Let's set this up. Let's get rid of that. Alright, so the goal is here, we're going to be given the length of the base, and we're going to be given these 2 angles. In fact, let me mark these as an isosceles triangle. We probably haven't seen these markers since geometry, but I just want to indicate that this is an isosceles triangle. So the goal is to find the altitude. So in this case, we're given that angle theta is 52 degrees. And since these are isosceles triangles, and these 2 sides are congruent, that means these 2 angles will be congruent. If we remember from geometry, in an isosceles triangle, the 2 angles opposite the 2 congruent sides are also congruent to each other. There's that theorem. And then we're given that the base is 8 inches. So this time they're actually giving us a length measure. This means the whole base. What we need to find is the whole altitude. Well, let's do that here. Let's find the altitude. Now, in an isosceles triangle, if you remember, another theorem from geometry is that in an isosceles triangle, the altitude of the triangle is also the perpendicular bisector of the triangle. Which means that it's, of course, the altitude's always perpendicular to the base, but perpendicular bisector means it's not only perpendicular, it bisects the base. So it's going to, and it's probably not the best representation, yeah. That's why I never took up art class. Okay. Well, a rough representation here. So that means that altitude A is perpendicular to this base at its midpoint. That means that half of the base is 4 inches, right? Half the base is 4 inches. Well, how can we find that altitude? You already these are split into 2 right triangles. You already know a side of the right triangle and you know an angle measure. So let's look at what we have here. If you take the tangent of 52, that would equal that side A over 4 inches, which would give you the length of the altitude. So the tangent of 52 degrees would equal that side A over 4 inches. So that means that side A equals 4 inches times the tangent of 52 degrees. And now we should be able to get a 2 decimal place approximation for the altitude. So we just take 4 times the tangent of 52 degrees. You get about 5.12 inches. So the altitude has a height of approximately 5.12 inches. So that actually wasn't that bad. Finding the altitude's actually pretty simple. I'll keep the altitude markers up. We might as well, because I'm just going to go based off the same triangle, honestly. Let's see what we got here. Theta is 18 degrees. the base has a length of 12 meters. That's for the whole base. Well, again, the altitude is perpendicular to the base at its midpoint, so it's the perpendicular bisector. So that means that this splits the isosceles triangle into two right triangles, and perpendicular bisector means this length would be 6 meters. So now, if we take the tangent of 18 degrees, that's going to equal that altitude A over 6 meters, which means that A equals 6 meters times the tangent of 18 degrees, which now we should be able to get a 2 decimal place approximation for the height of the altitude. So 6 times the tangent of 18, wow, that's a short altitude, gives you about 1.95 meters. So the altitude is approximately equal to 1.95 meters. That was a short altitude. Two more of these, then we're done with the lesson. Alright, angle theta is 41.6 degrees. So 41.6 degrees for each of those. The base is 18.5 feet. So that means the altitude is going to be right at the midpoint of this side. So half of 18.5 is 9.25 feet. So this here is going to be 9.25 feet. And now, all we have to do is take the tangent of 41.6 and we can get side A. So the tangent of 41.6 degrees equals that side A over the adjacent side of 9.25 feet. Which means that side A, the altitude has a length of 9.25 feet times the tangent of 41.6 degrees. So now we should be able to get a 2 decimal place approximation for the height of the altitude. So 9.25 times the tangent of 41.6 gives you an altitude height of about 8.21 feet. So the altitude has a height of about 8.21 feet. And I got just one more, then we are done with the lesson. All right. So angle theta is 72.94 degrees. So here's the 72.94 degrees. What's the base? Very small base of 3.26 centimeters. That is a very small base. So that means then we need to find half of 3.26, and we could end up getting the length of the right triangle at the bottom here. So half that base, 3.26 divided by 2, that gives you 1.63 centimeters for half of the base. Alright, so now we can find the altitude fairly easily. Just take that tangent of 72.94 degrees. set that equal to your altitude A divided by that 1.63 centimeters. So then the altitude equals that 1.63 centimeters times the tangent of 72.94 degrees. And let's get a 2 decimal place approximation, and then we'll have the height of our altitude. Alright, so 1.63 times the tangent of 72.94, and you get an altitude of approximately 5.31 centimeters. So the altitude has a height of approximately 5.31 centimeters. So that's it for this lesson. Now, in the next lesson, we're going to continue and still in trigonometry, but we're going to get more into analytical trigonometry. So that's going to be a lot more of trig identities, like doing some more complex identities of ones we've already learned, as well as learning some new identities and even solving some trigonometric equations. So I hope everyone has a great day. Take care.